All right, here we are in chapter 3 on polynomial and rational functions. And this is section 3.3 on power functions and polynomial functions. So what is a power function? Well, it's a function with a single term that is a product of a real number and a coefficient and a variable raised to a fixed real number. So it's represented by, so we have this constant k times a number or variable rather raised to some fixed power. So k times x to the p, where k and p are real numbers and k is known as the coefficient. Okay. Now, what are some power functions? Okay, well, if we think about this, can we rewrite each of these here on the left as something like k times x to the p to make it a power function? Well, 1, yeah, we can do that. And what we have to do is we have to say, well, it's 1 times x to the 0. Okay, because if we take anything to the 0, it's 1. So 1 times 1 is just 1. And so, yeah, we can do that as a power function. What about x? Well, here 1 is the coefficient, and so it's 1 times x to the, well, here this is known as a 1. Okay, so that is also a power function. And then we think about that, well, that's just 1x squared, so yes. 1x cubed, yes. Well, what is this? Well, this is really just x to the negative 1, and so it's 1 times x to the negative 1, and so yeah, that is 2. And the same thing goes for this. This is 1 times x to the negative 2. This is 1 times x to the 1/2, because that's what a square root is. And this is 1 times x to the 1/3. And so, as we can see, we go down and go down, we getting them. But what about this one? Well, this one, our exponent is x. And because of that, we cannot rewrite this no matter what we try to make it like this and to a power function. So that is a no. We cannot do that one. Okay. Well, what about this one? Well, this case we're using r instead of x, but that's still a variable. Pi is just a number, so it's some number times an r squared, and so that is a power function. Well, what about this one? Well, what we'd have to do is we'd have to multiply 2 times 4, and we get there 8. X squared times x cubed, we add the powers, so 2 plus 3 is 5. 8 times x to the 5th. Well, now our coefficient is 8, and we have x to the 5th. So yeah, we can do that one. Now this one we're adding. We don't have like powers, and so no matter how we do this, we can't simplify this into just a simple k times x to the p. It's going to be k times x to the p plus k times x to the q plus k times x to that. And so we can't rewrite this one also into the power function. So it's the second no. What about this one? Well, we can take x squared, raise that to the third. 3 times 2 is 6, so it's 1 times x to the sixth. So that's how we can look at different functions, rewrite them into a power function, or not in the case of those two. And that's how we can kind of identify those power functions. All right. Well, what if we want to identify the end behavior of a power function? Well, for functions of the same family, we can get a generalized view. Okay, and that's going to be something like x to the even or x to the odd. Okay, so let's start with the evens. So on the left over here, we have x to the n power, where n is going to be even. And we're going to say, start with x squared, then x to the fourth, x to the sixth, x to the eighth, and so on. And the red one is our original x squared value. So that's what that is. And then we move in and we're going in further as we go. And so that's going to be our x to the fourth. And we move in a little further, that's x to the sixth. Then we move in further, and that would be x to the eighth. And as we can see, we're pushing them in, and we're kind of compressing them into the center as we change our exponent. Now, what if we have, instead of a x to the n, we have a negative x to the n? Well, what does that negative out in front of a function here mean? Well, that means we're going to flip it over the x-axis. And so what we've done is we've taken all of these and we've flipped them over that x-axis here. So now they're all going down. And so now we have a negative x squared. Well, that's going to be, again, our red one. And then we're going to move in, and then it's going to be negative x to the fourth, move in again, negative x to the sixth, move in again, negative x to the eighth. So that's kind of how it is. And as you can see up here, we're broadening it. So instead of moving in here, we're moving it out because we need to have going through that point there and that point there. So what happens is it broadens out to make it come up to go through there. And the same thing over here. We're needing to go through that point there and that point there. When we do it, And so when that happens, it spreads out here and then it shrinks and compresses in at this point here. So that's when we have n is even. What about n is odd? Okay. Well, our normal typical x to the third is the first one, and that's the red one. And so, that's the general shape. And what happens then is, as we go up to the next odd one, x to the fifth, well, that's going to come in and it's going to compress it in. And we're going to widen it here. We're going to compress it in up here. And again, it's because we're going through that same shape. So to get that, we have to have that flattening here and compressing in this area here. And what happens when we have a negative instead of a positive x to the n? Well, we're just taking our original x to the, say, third, and we're going to flip it over the y-axis. And so it comes over here, and then it comes down, and then it does that. And so that's what we see on this right side over here. And this would be our red one's going to be a negative x to the third, and then we go in, it's going to be a negative x to the fifth, negative x to the seventh, negative x to the ninth, and so on. And as you can see, again, it broadens out here, but now we've flipped over the y-axis. Remember, when we have odds, odds is going to flip over here like this, and when we have evens, it's going to be flipping over like that. Okay. All right, so this is our general kind of a formula. So one thing to remember is f of x is equal to y. So when you see something, sometimes we might have f of x is equal to 3x plus 4, just a simple linear function. Well, we can also say that's y equals 3x plus 4. So we're interchanging these two notations, okay? All right, so when we have a positive constant, k greater than 0, so basically, we're up above, we're positive, these are our two general forms, even power, odd power. And if we go back, that's basically what we saw here. Even power, that's what we saw. Odd power, that's what we saw. Now what we want to do is we kind of want to think about going to the end behavior of these. So as x goes to positive infinity, what does y do, or what does f of x do? Well, it's going to positive infinity as well. So as x goes to positive infinity, f of x goes to positive infinity. Now what about x going to the negative infinity? Well, it's still going to positive infinity for y. So as x goes to negative infinity, f of x goes to positive infinity. And so what we need to do is get used to writing a notation like this for something like this. And so we're looking at the end behavior. Well, it's continually just going up. Now, if we have the odd, what happens there? Well, as we go to the right, it goes up. And so we're going to the positive infinity as x goes to positive infinity. So that's the second line. And now what happens if we go to negative infinity? Well, we're going down to negative infinity. So as x goes to negative infinity, f of x goes to negative infinity. And this is for odd and even with k greater than 0. Okay, so that would be like your x squared, or in this case, your x cubed. Okay. But if we have a negative constant, k is less than 0, so say we have a negative x squared or a negative x cubed, what happens is this one we flip over this axis, and so we come over here and we come over here, and that's going to happen. And so we have now they're both going to negative infinity, whether we go to positive x or negative x going to infinity. And so either one of those we get going to negative infinity. Now, what about this one? Now, this one you can also think, if you need to think about it flipping across that x-axis, well, then this, comes down and this goes up. And so it's the same thing as flipping across the y or flipping across the x in this case. And so here we're going to go to positive infinity as x goes to negative infinity. So that's this one. As x goes to negative infinity, we're going to positive infinity. And this one goes to negative infinity as x goes to positive infinity. And so as x goes to positive, f of x goes to negative. And so that's, again, the kind of notation we need to think about as the end behaviors of our functions. All right, so what we need to do now is we need to think about, okay, determine the end behavior of the given power function. So what we're going to do is we're going to first draw a general form, okay? And so x squared, so that's a positive. So that one is n is even. We have k greater than 0. And so it's going to look something something like this. And so what we have is as we keep going each direction, we're going to positive infinity for y, and x is going to be varying. So what we'll say is the end behavior. As x goes to negative infinity, f of x goes to, well, as x goes to negative infinity, it goes to positive infinity. And as x goes to positive infinity, f of x is going to go to also positive infinity. It's going to go up, okay? All right, what about this one? X to the odd. So here n is odd, and we have k less than 0. So if we remember, our original function for odds are like that. But when we have that negative out front, we have to flip it over. And so now it comes down like this. Okay, so, again, we flip over the y-axis or flip over the x-axis, we get the same picture here. And so what we get? Well, it's going to positive infinity as x goes to negative, and as x goes to positive infinity, it's going to negative infinity. So as x goes to negative infinity, f of x goes to positive infinity. So we're going up that way. And as x goes to positive infinity, f of x goes to, now we're going to negative infinity. Okay. And so that's how you can do it. Again, what we can do is we can just draw a general, picture of an even function or an odd function, k greater than 0 or less than 0, and then just look at how does it look, where is it going to? And so it's going to positive infinity both ways, whatever way x is going. Here, as x goes to negative, it goes to positive, and x goes to positive, it goes to negative, okay? And that's how we would write it. So this as well as this. All right, let's pause there and I'll be back.